A checksum is used to verify the integrity of data. This is done by performing a checksum function that is comprised of complex mathematical procedures on the input data. This results in a unique value derived from that input data. Any changes to the input data will cause a different checksum to be calculated. A checksum can be thought of as the fingerprint of data. Suppose I would like to calculate the checksum of this Rubik's Cube. In its current state, which is a solved state in this case, I will run it through a checksum function and a checksum will be generated. This checksum will take the form of a bunch of numbers and letters, or it could just be numbers or letters. The sample checksum could be something like FDACB134. This is a hexadecimal number that represents a checksum, or a sample checksum of this cube. Now, let's suppose I turn one of the faces once. Now, the cube is in a completely different state, and if I were to run the checksum function again, I will get a completely different checksum, something like C49DCABF. If I alter the cube again in a different way, this will yet again result in a completely different checksum. So basically, every state of the cube will have a unique checksum. If I were to physically alter the cube like this by rotating one of the corners once clockwise, and this will yet be another checksum. But this cube is now no longer solvable. If I try to solve the corner, you can see that the rest of the cube is completely messed up. If I try to fix the messed up portions, now that corner is messed up itself. This is known as an invalid state. The cube is no longer solvable. If this were to represent useful data, and the data is supposed to look like this, but it is actually like this, a checksum will be able to verify that by comparing the checksums between the original data and the damaged data. And this is how a checksum can be used to verify the integrity of data.